Welcome back. This is the 9th lecture for project management, and if you remember the last slide based on which we ended the 8th lecture was related to the different techniques from the financial point which are there, like IRR, then interest rates, rate of return, expected value, so on and so forth, based on which you can take a decision whether the project is at all feasible and how you can compare different projects. So, and just before that, 2 or 3 slides before that, we consider the concept of decision trees and how expected value and variance would be utilized. So, now I will just try to analyze from the point of view of risk analysis. So, our plan for this set of lectures, I am very specifically mentioning this important point of the plan would be, once I finish the risk analysis, then I will definitely do problems in related to 3 broad areas. One would be the decision trees, one would be the different type of financial concepts, and then come to the concept of the risk analysis, how it can be undertaken. For an outcome, be it financial or a project. So, for our case is only a project. If we are assured that it is sure to give us a tangible benefit, then we are not concerned about the chance that it will not happen, and the corresponding probabilities would be very specific to that particular activity, which will say that whether there is 90% chance, 95% chance, 70% chance whether the work will be done or not. But in reality, we know that maximum of the cases of the activities or the jobs or any decisions we have to face, the game of chance comes, and hence one should be aware of the probabilistic nature of the distribution and the return, based on which you will take a decision whether that activity or the job should be taken into action. So, for an outcome, consider any random outcome, whether you are buying, the project can be, as I mentioned, it can be anything, building a bridge, building a house, taking a project to design a car, whatever it is. Consider that as x, which is just a variable based on which we will do the calculation, and we will use the concept of probability, where x is a random variable. Corresponding to this random variable capital X, we have an average or a mean value. So, this average and the mean value would basically mean that what is on an average the so called value which you will get from x. So, if you remember, if you roll the die and if it is basically an unbiased die and there are 6 faces. So, the probability of getting either 1 or 2 or 3 or 4 or 5 or 6 is everything is 1 by 6, because 1 by 6 added up 6 number of times is 1, which is the concept of the probability which we all know. So, if you want to find out the expected value of the outcome, what we generally do, as we all know, is that multiply the outcome which is there, which would be either 1 or 2 or 3 or 4 or 5 or 6 for the case of rolling the die, and multiply each term which is there, which are the realized values of the random variable x, and you will multiply them by 1 by 6. So, this is done where you will basically have 6 here, and why I have put in the bracket, because 1 by 6 is the probability which is common, you can take it outside. So, technically it is 1 into 1 by 6, 2 into 1 by 6, 3 into 1 by 6, 4 into 1 by 6, 5 into 1 by 6, 6 into 1 by 6. This will give you the expected value of x, and what is the formula based on which we are trying to do that, I will come that within 2 or 3 slides. So, the cost of uncertainty for such a decision, if it is an expected value, would be risk, and if we remember, I did mention risk time and again. At one point of time, we were basically discussing risk as the overall loss in a monetary sense, but basically risk means that for any decision which is probabilistic, non-deterministic, the concept of dispersion or variance come into the picture. So, risk is usually denoted by the variance. So, given by sigma square is equal to the expected value of in the bracket x minus E of x. X is already the expected value we know, whole square. So, there are other quantifiable ways of denoting the risk, but for all practical purposes the second moment. So, this is the second moment based this is not the second moment. So, based on the second moment we find out the concept of sigma square. So, the second moments of a random variable are utilized, which suffices to quantify this risk. Other measures of risk would be, can be skewness, which is the third moment for calculated from the third moment, it can be kurtosis, so on and so forth. So, these formulas are given for the skewness. If you see, it is given Ex cube, Ex4 and so on and so forth. But we will only concentrate on risk concept, of which is the second moment. So, if we have x as a discrete variable, then we have the formula which is given, that if it is discrete, then the expected value would be found by summation of xi's. So, xi's are the realized value multiplied by the corresponding probabilities, and then you sum them up. So, if the problem which we just did very fleetingly, trying to find out what is the expected value of the outcome when you roll the die, was basically 1 by 6 into 1 till 1 by 6 into 6. So, these 1, 2, 3, 4 are the realized value, 1 by 6 is the probability. And if you want to find out the variance, use the formula which is basically the summation of that squared term, x which is the realized value minus the expected value, and the whole thing multiplied by the corresponding probability. If x is continuous, not discrete, then you rather than using the summation sign, we use the concept of integration. So, this is basically the x fx dx, or in this case we can use d of capital F of x, considering the distribution function is given, while this small f of x is the PDF, while capital F of x is the CDF value, which we all know and must have done all these things. All of you must have done these things in class either 12 or in basic engineering and probability and statistics. So, similarly for the continuous variable, the variance is calculated whether inside term remains the same, just you basically integrate it from minus infinity to plus infinity, which are the limits for the minimum value of x and the maximum value of x which you have. So, consider this in the risk return framework. So, this the word I am using for the first time, where the return on the expected value and the risk of the variance or the standard deviation. Now, what we mean by standard deviation, again I am sure all of the candidates who are taking this course, all the students are well aware, standard deviation basically means the square root of variance or the risk. So, we are trying to measure risk using standard deviation or variance along the x axis, and along the y axis we have the return, and this, rather than using any dots, I have just highlighted it using the squares or the rectangles which are different colored. So, what we have is project A, project B, project C and project D. So, what we want to find out is that what is the overall risk for these individual projects, and if a company, consider like L&T is building up a bridge in West Bengal, L&T is, say for example building a big government office in Bombay, L&T is also, say for example trying to build up a highway in, say for example state of Karnataka. So, in these cases these are all projects, and if L&T as a company wants to basically find out what is the overall risk for the whole set of projects, then it will basically try to very simplistically find out what is the risk and return framework from the risk perspective as well as the return perspective, and they basically combine them as so called consolidated portfolio or a consolidated set of projects, such that you can take a decision based on the overall risk and overall return for all the projects combined together, which is shown here in the blue rectangle, which is basically the combination A, B, C, D. So, your question would be that, do we combine A, B, C, D in the same proportions? Like consider L&T has limited budget. So, it wants to basically find out whether it can invest in all the 4 projects in some proportion. So, that is the proportion based on which L&T will make a decision. So, those proportions have to be found out using simple concept of optimization. I would not go into the details, but I will just give you a flavor that how it can be done. So, we will discuss the concept of portfolio theory, even though portfolio theory as a concept came up into existence in finance literature by the pioneering work of Markowitz, Harry Markowitz, who also won the Nobel Prize, and we will try to utilize that concept of portfolio optimization very simply when you try to find out what is the overall risk and return of a portfolio of projects as such. So, we discussed the portfolio theory as applied to managing financial assets. This concept will be utilized when we consider the idea of managing a conglomeration of projects. So, according to Markowitz's theory, we know that the riskiness can be characterized by the variance. This variance along with the covariance structure which would be there between two different projects that or between two different assets. So, I will be using interchanging the words assets and projects, even though it is only relevant to the projects as such, but just for the sake of explanation it will be easier for us to make no distinction between the concept of an asset and a project for the discussion for these slides and the subsequent 3 or 4 slides. So, we know that the general form of the optimization problems we want to formulate, we will do that. Now, the question is that how we reduce the minimization of the collective risk of the set of the assets or the project. So, method of reducing is known as basically trying to diversification, like not putting all the eggs in the same basket. So, I have used this term in 1 or 2 lectures before. What you are trying to do, you are trying to basically put them into different buckets or baskets so that the overall risk is basically minimized to the maximum possible extent. For ease of understanding, consider the very simple hypothetical case when there are n number of such projects, n number of assets. So, if you remember the slide where the x and y axis were there which was return and risk. So, these points which are there for the different projects. So, there are such n number of dots which are there which basically signify n number of projects. So, for each project there would be return and risk which I am trying to basically draw using the vertical one and the horizontal one. Vertical one basically would mean the risk, this is the standard deviation if you remember, and this is basically the return or the expected value. So, the vertical would basically mean the risk, the return sorry, and the horizontal would basically mean what is the value of the risk. The prices of the assets of the projects are moving in such a way that their respective prices are for the time being considered they are uncorrelated. So, if they are correlated, what are the consequence? I will slowly go into that. The return of each asset has an average mean value of m for this example, which is very simplistic. What is the general formula? I am going to come to that and try to explain that. The variance of the risk of the project or asset is given by sigma square. That means, for each of them are the same, which may not be true in actual practical purposes. Similarly, the return of each asset project being equally being same as m may not be true in the practical sense, and also the word that they are uncorrelated exactly may not be the same in the practical sense. So, what is the general formula? I will just put it on this slide for the ease of understanding of the students. And finally, weights. If you remember, I mentioned that L&T has 3 projects, Calcutta, Bombay and Karnataka, that bridge, the building and the highway. So, in those cases if they want to invest, if they have 100 crores, they want to invest some proportion. So, that proportions is basically what it signifies the 4th point. Here we are saying the weights for each asset or project considered in the portfolio are of equal proportion. So, if you have n numbers of projects, obviously it would mean 1 by n for each. Again, it is a very simplistic assumption. So, now what we have in consideration, if I remember, I just mentioned that I will write the first the general formula. So, if I consider the overall risk of the set of so called portfolio of assets or portfolio of projects which I have, it would mean that it is Wi, Wj, sigma ij, where I is equal to 1 to n, well j is equal to 1 to n. Now, this Wi and Wg are the corresponding weights which is being invested for asset I and asset j, while sigma ij is basically the covariance structure or the covariance value which is existing between asset I and asset j. Now, if you expand that, and obviously remembering the fact that I is equal to 1 to n and j is equal to also 1 to n. So, they can be values where I and j are exactly equal. So, if they are equal and if you try to basically draw this concept or the formula which I have written using the concept of a matrix. So, this matrix would be of a size n cross n. Why n? because if I try to find out the values of the covariance of the first to the first to the second, so on and so forth. So, they would be plotted along the topmost row. Similarly, if I have the second asset again or the project on the second row, and similarly for the nth one on the last row, corresponding to the fact if I again delineate or draw the first asset along the first column, the last asset along the last column. So, if you understand this is the n cross n matrix with the principal diagonal, if you consider. So, I will just try to utilize a different, yes, this highlighted one, green one, this yellow one which you have. This is the principal diagonal where the corresponding 1 1 element, 2 2 element, 3 3 element till the case of the n n element basically means the covariance of the first asset of the project to itself, covariance of the second asset or the project to itself till the last term which is the n position, which is the covariance of the nth asset to itself, which means basically the variance of the first asset, variance of the second asset till the variance of the nth asset. While the off the diagonal element which you have, so again I will try to change the color. So, these element or this element, they are exactly opposite to each other if you consider the principal diagonal. So, the element which is on the second column first row and the element which is in the first column second row is basically the covariance of the first asset or the project to the second one or vice versa. So, if I write it down, it basically would mean sigma 1 2 is equal to sigma 2 1 is equal to rho, which is the correlation coefficient multiplied by sigma 1 multiplied by sigma 2. So, I will use the suffix 1 2, which means the correlation coefficient existing between the first and the second. Now, this sigma 1 and sigma 2 are the corresponding standard deviation of asset 1 or project 1 and standard deviation for asset 2 or project 2, which is basically the square root of sigma 1 square, square root of sigma 2 square. While this rho is basically the correlation coefficient. So, if you consider the principal diagonal, technically it would be the first 1 1 element, or say for example, the n n element, it is sigma 1 1 multiplied by sigma 1 multiplied by sigma 2. So, rho 1 1 basically means the correlation of the first to itself, which is 1. Similarly, the correlation of any asset or project with itself would always be 1, while this one, sorry, this is 1. This would mean that this is the standard deviation of the first multiplied by the standard deviation of the first again, which is again if you consider, it comes back to the variance. So, all the principal diagonal are the variances, off diagonal element are the covariances. So, off diagonal element on the first top half is exactly the replica of the second half, because the covariances of 1 to 2 or 2 to 1 are exactly the same. Now, if you see this formula, if you expand that and then consider these 4 points 1, 2, 3, 4, and the simplistic assumption which I mentioned in the practical sense, 1 is not true, 2 is not true, 3 is not true, 4 is not true, what are those? Uncorrelated means there is no correlation coefficient, which means the correlation coefficient for the first to the second or the second to the third, whatever, are all 0, which means the off the diagonal elements, none of them exist. So, only you have basically is the principal diagonal is the variance of first, second, third, fourth, that means there are n such elements. Second one being the point is that, which is also simplistic, the return of each asset project has an average value which is m, which means that if you are trying to find out the return is basically calculated by summation of Wi, and this sigma is the standard deviation of the return. So, average of the return I will consider as r I bar, bar means the average. This r is the return, which is the same concept which we just discussed in few slides back about the IRR and how the internal rate of return and the rate of return for the banks, which basically pays to you if you deposit your money, or for the project returns are basically R's only. So, it makes sense in order to find out the average value of the return. So, if I want to find out the average value of the whole set of projects, it would basically be the corresponding weights multiplied by the average return for each project or asset which you have, and then sum it up, because if there are n, you have to basically sum them up for all the n's. So, in this case what we are assuming for the this is for the whole portfolio. Now, if you see the second point, it means that for each of them are same, that is the return of each project, this RI bar are exactly the same. So, that means each of them gives you the same return of M. The variance of each asset project is sigma square. So, again coming back to the first point, we saw that we had only the principal diagonal, of the diagonal elements are 0. So, again to take it one level further, we consider each element in the principal diagonal are exactly the same. So, we do not have sigma 1 square, sigma 2 square, sigma 3 square, those are not there. Only thing is there, each variance is sigma square by itself. For the variance for the first project or the first asset, second project, second asset, third project, third asset, everything is same. Finally, if you go to the fourth point, which is the weights of each assets are exactly the same, it means that WIs which you have, as if you remember, if you have such n projects, we are considering that each of them investment being done in any asset or a project is exactly equal proportion. So, if you add up 1 by n number of times, it exactly becomes 1, which should be the case. So, if you draw this risk return framework for these 4 simplistic assumptions for the formulas, you will see the return on the project is M, because you are adding up RIs n number of times and all of them are the same value. So, basically they cancel out and this is M, and the variance, if you remember, you want to find out the using the concept of probabilities, concept of statistics, the overall portfolio for the set of portfolio for the project basically becomes sigma square by n, because the square term comes, hence it becomes n, which means that if you draw on the risk return framework, the value of the return. So, here I am not drawing the return to the risk, I am trying to basically find out the risk with respect to the number of such assets which I have or number of projects which I have in my portfolio. So, overall risk of the total set is given on the y axis, number of such investments for the projects is given on the x axis. So, if you consider as n increases, this will decrease as shown in this diagram. So, this is just an hypothetical example to make you understand that as the value of n increases for such a portfolio, theoretically it is possible to make the overall risk as 0. So, introduction of portfolio approaches are there. So, in order to diversification to be most effective, we should have projects in the same industry tend to be generally correlated. So, if there is two industry based on, say for example, coffee and tea. So, consider the products for which if the coffee price increases, we tend to assume that the tea price should decrease, because the consumption basically for tea then increases as coffee decreases. So, again vice versa. So, in this case the price movement are not positive correlated. So, the first point basically means that in the same industry, like if they are the car and the steel industry, where car industry uses a lot of steel. So, if they are in the same sector, or say for example petroleum products and car industry. So, if they are in the same type of sector, so they tend to basically move in the same direction. Projects or assets in different industries are not correlated. So, they move in opposite directions, and there can be some cases where the projects or the assets movements are totally irrelevant to each other. That means, their overall dependence structure is 0. That means, the correlation coefficient is 0. So, now we will consider the capital asset pricing model, even though it is basically applicable for finance, but still we will try to utilize it here. In order to do away with the enormous amount of calculation which is required when you are combining a large number of financial assets or projects, we use a proxy which subsumes or assumes that the expected value of any particular financial asset can be replicated by the market. That means, what we have, there is a market or so called theoretical set of portfolio of the projects, and each of the projects which is being undertaken by you as a company, or say for example some second party, third party, parties are basically different players who are there in the market. So, all of the projects individually or as a portfolio for them, or as an individual for you or a portfolio for your case, everything is related to the market. So, market is basically a very theoretical or hypothetical concept which basically considers the portfolio of all the assets or all the projects which can be taken up at any point of time, is basically the market. Like consider for the finance, you have the BSE Sensex or the NSE. So, which means that it basically gives you a picture how the overall financial market is doing, and all the assets which are there, the individual stocks like Tata Steel, Tata Motors, Reliance, Bajaj, Godrej, whatever they are individual assets or projects, and the prices of all of them are basically somehow related to the overall market. So, this is the concept of CAPM in general. Considering that there are only one variable which regulates the price movement. So, this one variable is basically what I meant was the market. The risk can be denoted by beta suffix I. So, you are seeing beta for the first time. Till now we have been discussing that risk is basically sigma or variance sigma square and so on and so forth, but beta is basically the overall risk when you consider the capital asset pricing model to be true, such that the relationship between the price movement of the ith asset or the ith project with the market is given by this simple formula, which means the difference between RI is basically return from the ith asset of the project, minus RF. So, RF basically you are seeing in the first time is basically the risk free interest rate. So, if you are considering say for example the project, so you have 100 rupees to invest in a project, and you want to basically compare that with the investment if you keep that amount of money in the bank. So, what would be there, you will try to basically understand whether the project would give you positive return or negative return. Positive in what sense? If the bank interest rate, fixed interest rate or the risk free interest rate is arbitrarily considered 10%. So, you will try to basically understand whether the project will give us a return greater than 10%. If it is not, obviously then the returns for the project would be with comparison to the risk free interest rate would be negative. So, what we want to find out is that as we are comparing the return on the project or the asset with the market, both the market as well as for your the decision for the asset or the project would basically be pegged against the risk free interest rate R suffix f. So, in the left hand side you have the difference between your project returns and the risk free interest rate, and on the right hand side what you have is basically the risk factor for your corresponding project or an asset with respect to the market multiplied by the overall excess return on extra return which the market would basically have over the risk free interest rate, which is RF. And this last term which is basically the white noise, which is basically the epsilon. So, generally if you consider the very simple equation which you have done in mathematics, y is equal to mx plus c, this bears some resemblance to that. The only fact is that Ri and Rm are stochastic, hence epsilon I which is the white noise is also stochastic. So, if you take the expected value on both the sides, Rf being risk free interest rate, the value remains same. So, what is interesting to be noted is that this epsilon which generally we consider has a normal distribution with 0 mean and 1 standard deviation. So, if you take the expected value on the left hand side, you will basically have Ri bar minus Rf, because Rf is constant, and on the right hand side beta I we will consider again outside the expected value, you will have Rm bar minus Rf. Rm bar is basically the expected value, and the last term expected value is basically 0 as per the assumption. So, if you consider this and this, it basically means that there is a straight line, this is the value of the intercept c, this is the tan of this angle, the tan of the angle is m, and based on that you try to basically analyze the problem. So, assuming normal distribution for the returns and also considering this. So, here either you consider 1 or sigma square, whatever it is, the main factor is h should be 0. We have the final equation as this, which I mentioned has some resemblance with the concept of y is equal to mx plus c. So, with that I will end this lecture. and in the next lecture we will try to cover the first set of problems from the decision trees and the concept of different type of financial not ratios, this interest rate, all these things, how they are used in order to basically understand the concept of project. And later on, after those two small problems in the area of decision trees and the financial things, we will try to cover the AHP and ANP in slight details with a simple problem. Thank you very much. Have a nice day.